Good morning, children. Today we are going to discuss few more examples where alcohols act as electrophiles. We already discussed when alcohols act as electrophiles, the bond between carbon and oxygen is broken. Now, today we are going to discuss the fourth example, that is oxidation. Oxidation of alcohols when alcohols act as electrophiles. Now, oxidation of alcohols will result in the cleavage of OH and CH bond. But we already discussed when alcohol acts as electrophiles, the bond between carbon and oxygen is broken. But in oxidation reactions of alcohol, the bond between OH and CH is broken and it results in the formation of C double bond O. That is, a carbonyl compound is formed. Now, look at the example written. CH3OH. On oxidation, you can see the bond between CH. Any of the CH bond can break and the bond between OH is broken and it results in the removal of H2 gas. H2 gas. Now, also we get the product where a double bond is formed between carbon and oxygen. That means we get a carbonyl compound. Now we can use different oxidizing agents. So based on the oxidizing agent used for oxidation, alcohols give different products. Now the common strong oxidizing agent used for oxidation is acidic KMnO4, potassium permanganate, or acidic K2Cr2O7, that is potassium dichromate. Now let's see the products formed when alcohols, different types of alcohols, that is primary, secondary and tertiary, react with these oxidizing agents. Now, oxidation of primary alcohol. Primary alcohol on oxidation with strong oxidizing agents like acidified potassium permanganate, we get aldehyde first, which further undergoes oxidation to give carboxylic acid with same number of carbon atom as the parent alcohol. Now look at the reaction CH3CH2OH. This is a primary alcohol. On oxidation with acidified KMnO4, KMnO4/H+. This H+ denotes that this is an acidified KMnO4. Now, on oxidation, you can see the CH and OH bond breaks and H2 is removed. And we get a double bond between carbon and oxygen and we get the product acetaldehyde, CH3CHO. And you can see the number of carbon atoms in aldehyde is 2 and the number of carbon atoms in the alcohol is also 2. Now, this will undergo further oxidation immediately to give carboxylic acid with same number of carbon atom as the parent alcohol. You can see there are 2 carbon atoms here and 2 carbon atoms in parent alcohol. So, this is the oxidation product of a primary alcohol with acidified KMnO4 or acidified K2Cr2O7. That is, primary alcohol will undergo oxidation to give first aldehyde, which again undergoes oxidation to give carboxylic acid with same number of carbon atom as the parent alcohol. Now let's see. Suppose we want to stop the oxidation at aldehyde stage, means we don't want this aldehyde formed to get oxidized to carboxylic acid. So instead of using acidified KMnO4, we have to use some other oxidizing agents. And the oxidizing agent used to get only aldehyde is PCC. PCC. And the full form of PCC is pyridinium chlorochromate. And this pyridinium chlorochromate is a complex of chromium with pyridine and HCl. Now look at the examples written here. CH3CH2OH, this is a primary alcohol. On treatment with PCC as the oxidizing agent, that is our pyridinium chlorochromate, we get CH3CHO, which further does not undergo oxidation. Now the next example, that is example 3, is with another oxidizing agent, that is with chromium trioxide. So chromium trioxide is another oxidizing agent which can be used to stop the oxidation of primary alcohol at aldehyde state. You can see this example 3, CH3CH2OH on treatment with chromium trioxide, you get aldehyde as the product which further does not undergo any oxidation. Now I have written one more example here, example number 4, CH3CH double bond CH2OH. You can see the CH and OH bond breaks and a double bond comes between carbon and oxygen here. That is our CHO group. Now this is the double bond of that alkene part that remains as such. The double bond is formed between carbon and oxygen and it results in the formation of aldehyde, and this aldehyde will not go oxidation further to give carboxylic acid. So this is the oxidizing agent, that is with the help of PCC or chromium trioxide we can stop the oxidation of a primary alcohol at aldehyde stage. Now next is oxidation of secondary alcohols. Oxidation of secondary alcohol. Secondary alcohol on oxidation with acidified KMnO4 or acidified K2Cr2O7 will give ketones first with same number of carbon atom as the parent alcohol. Now these ketones will further undergo oxidation to give a mixture of carboxylic acids, both containing lesser number of carbon atoms than the parent alcohol. Now look at the example 1 written on the board. CH3, CHOH, CH3. And you know this is a secondary alcohol, CHOH, because the functional group attached carbon is attached to 2 other carbon atoms. So this is a secondary alcohol. On treatment with acidified KMnO4, the CH and OH bond breaks and we get C double bond O. So you can see the product here, CH3, COCH3, which is a ketone. And the name of this ketone is propanone or acetone. Now, this ketone contains same number of carbon atom, 1, 2, 3. Same number of carbon atom as the parent alcohol, 1, 2, 3. Now this ketone will undergo further oxidation to give a mixture of carboxylic acids. This is one carboxylic acid, that is acetic acid, CH3COOH, plus this is the second carboxylic acid, that is formic acid, or carbon with acid with one carbon is known as methanoic acid. Now you can see this mixture of acids contain lesser number of carbon atoms than the parent alcohol. There are 3 carbon atoms in the parent alcohol, but in the acid formed we have 2 here and 1 here, but the total number of carbon atoms remains the same as parent alcohol. Now again, suppose we want to stop the oxidation at ketone stage, then secondary alcohol on treatment with PCC or chromium trioxide, we get ketone which will not further undergo any oxidation. So this is the oxidation reaction of secondary alcohols. Secondary alcohol on oxidation with strong oxidizing agents like KMnO4 or K2Cr2O7 will get oxidized to ketone which contains same number of carbon atom as parent alcohol. The ketone formed will undergo oxidation to give mixture of carboxylic acid, each containing lesser number of carbon atom than the parent alcohol. Now the next oxidizing agent used is PCC, pyridinium chlorochromate or chromium trioxide, where we can stop the oxidation of secondary alcohol at ketone stage. So we get only ketone as the product, which will not further undergo any oxidation. Now tertiary alcohols. Tertiary alcohols do not undergo oxidation under normal conditions. Okay, so with this KMnO4 or K2Cr2O7, oxidation will take place only for primary and secondary alcohol. Tertiary alcohols will not undergo oxidation. Now, you can write this oxidation of primary, secondary and tertiary alcohol as a test to distinguish primary, secondary, tertiary alcohols. Already we have discussed another test, that is Lucas test, for the test to distinguish primary, secondary and tertiary alcohol. Now, this also can be written as a test to distinguish primary, secondary, tertiary alcohol. And you know, primary alcohol on oxidation gives aldehyde, which undergoes further oxidation to give carboxylic acid. Secondary alcohol will give ketone, which undergoes oxidation to give mixture of carboxylic acids, and tertiary alcohol will not undergo oxidation. Now, next catalyst used for oxidation is oxidation using copper catalyst at 573 Kelvin. This temperature is very important, 573 Kelvin. Now, this also can be used as a test to distinguish primary, secondary and tertiary alcohol. Now, primary alcohol on oxidation with copper catalyst at 573 Kelvin, you get aldehyde as the product. Again, this involves the breakage of CH and OH bond and we get aldehyde as the product and H2 is removed. Secondary alcohol on oxidation with copper at 573 Kelvin gives ketone as the product. Now, this also involves the breakage of CH and OH bond and we get ketone as the product. So, you can see the oxidation of primary and secondary alcohol with copper catalyst at 573 Kelvin, it involves dehydrogenation reactions. Now, tertiary alcohol with copper catalyst at 573 Kelvin will give alkene as the product. Means it does not undergo dehydrogenation, instead it undergoes dehydration, that is removal of H2O. So, tertiary alcohol, so this is the only oxidizing agent with which the tertiary alcohol will undergo oxidation. That is copper catalyst at 573 Kelvin and the product formed is an alkene. Now, I told you this can be written as a test to distinguish primary, secondary and tertiary alcohol. Primary alcohol on oxidation with copper at 573 Kelvin will give aldehyde. Secondary alcohol will give ketone. Tertiary alcohol will undergo dehydration to give alkene as the product. Now, I have written 3 examples, each with primary, secondary and tertiary alcohol. Example 1 is primary alcohol. On oxidation with copper at 573, we get aldehyde with same number of carbon atom as the parent alcohol. Example 2 is a secondary alcohol with copper at 573 gives ketone with same number of carbon atom as parent alcohol. Example 3 is a tertiary alcohol with copper at 573 Kelvin. You can see H2O is removed, that is OH from here, and hydrogen can be removed from any of the beta carbon atom. Now, this is alpha carbon, so these 3 can be beta carbon and I have removed it from this carbon. So, here we get a double bond in the product and you get alkene as the product. This is our alkene plus H2O is removed. So, this is the oxidation reactions of alcohols. And both the oxidation reactions can be used as a test to distinguish primary, secondary and tertiary alcohols. Now, you can see in all these reactions written, I have not written any example with phenol. That is because the breakage of CO bond is given only by alcohols. And phenols also give one example or one reaction, that is the reaction of phenol with zinc dust where CO bond is broken, which will be discussed under chemical properties of phenol. So, with this we finish the portion where alcohols act as electrophiles. Now, I am going to discuss one more topic, that is the last topic coming under alcohols properties, that is some commercially important alcohols. You have to learn two alcohols, their preparation and properties of these two alcohols, which are very important commercially. The first one is methanol. The formula of methanol is CH3OH. Now, the preparation of methanol is catalytic hydrogenation of carbon monoxide. At high temperature and pressure, we get methanol. Now you can see I have written the equation carbon monoxide plus hydrogen in presence of catalyst zinc oxide and chromium trioxide at pressure 200 to 300 atm, temperature 573 to 673 Kelvin, we get methanol as the product. So this is the preparation of methanol. Now regarding the properties, methanol is a colorless liquid and it is poisonous. Ingestion of small amount of methanol can cause blindness as well as it may lead to death. Now, methanol uses of methanol, it's used as a solvent in paints, varnishes, and it's also used for the preparation of formaldehyde. Now, the second commercially important alcohol is ethanol. Ethanol, the formula of ethanol is C2H5OH. Now, preparation of ethanol is from sugar. Now, you know the molecular formula of sugar is C12H22O11. So, sugar from molasses or sugar cane or grapes will get converted into glucose and fructose in the presence of enzyme invertase. This is a catalyst. Invertase acts as a catalyst. So, sugar is first converted to glucose and fructose in the presence of invertase. And you can see the formula of glucose and fructose is the same, C6H12O6, C6H12O6. Now in the second step, glucose and fructose both will undergo fermentation in the presence of enzyme cymase, which is found in yeast, to produce ethanol with the liberation of carbon dioxide gas. And this fermentation of glucose and fructose must be done under anaerobic conditions, that is in the absence of air. Suppose air is present, in that case the alcohol will get a foul taste. Now next comes denaturation of alcohol. Denaturation of alcohol means the ethanol, it is made unfit for drinking by adding certain additives. We can add methanol because you know methanol is poisonous. Now we can give color to this ethanol using copper sulfate. It gives a blue color to alcohol. Also we can add a foul smelling liquid called pyridine to make ethanol unfit for drinking. And this is called denaturation of alcohol. So with this the commercially important alcohol gets over. Thank you.